Hi buddy, and today we're going to be doing 3D shapes. So just a disclaimer, everything you should know for doing 3D shapes, you should already be pretty good at. Primarily trigonometry, cosine, sine law, cos law. You should be excellent at these, and they're really the foundation to these questions. So in general, in this lesson, I won't be teaching you anything new. In fact, you'll probably be using what you already know from trigonometry to be solving these questions. They're pretty self-explanatory. So you have this, let me turn on my pen. You have this question shown below is a cuboid. Now, what exactly is a cuboid? You know, probably from the graph, it's a rectangular prism, right? And length AG is 16 centimeters, which is labeled here. Angle CAG is 35 degrees, as labeled here. Now you must work out the length of EG. Let me just draw a line from E to G. So at first you might recognize that the angle is not touching EG whatsoever. And it may be a block for you at first until you realize that EG is in essence the equivalent of AC. This is because it is a cuboid and therefore these two sides must be equal. And now it becomes so much more simpler because you can draw a diagram here. This being AC, which is what we're trying to find, X. And this is 16 for what we know, and this is 35 degrees. Now it becomes a really simple question. Of SOHCAHTOA, we have cos 35 because that is adjacent over hypotenuse, and adjacent over hypotenuse. And now that we have this, we have 16 cos 35. And what about your calculators? That would give you a total of 13, keep hold of the unit, 13.1 centimeter. Now, in terms of rounding, you always refer back to the question. But in this case, there doesn't seem to be any instructions on rounding. So in your therefore statement, you would say that the length of EG is equal to 13.1 centimeter. Now, next question. Shown below is a cuboid. So we have the exact same sort of shape, and now we're trying to find the angle between AG and the plane EFG. So unlike the previous question, as you probably noticed, this is not labeled. So we must label this by ourselves. We know that EG is equal to 7 and AG, which you have to kind of visualize this angle, is equal to 11.5 centimeters. Now, you must work out the size between the angle of AG and the plane EFG. Now, this is really, really important when solving these questions. You must understand what this means. The plane of EFG simply refers to the side, this entire sort of rectangle that encompasses the points E, F, G, and H. Now, what does it mean exactly for it to essentially be between an angle and a plane? This is where many students get stuck, but you really have to think about it. Use common sense. AGF would be a slanted angle and simply wouldn't be realistic to find out. AGH is the same situation. So you must infer and say that AG, it must cross over the plane. So it goes from AGE. So instead of saying this, it is essentially asking for the angle of AGE. Now, we already know two values, so let's just draw the angle here. This will be theta, and this is 11.5, this is 7. And now you can just easily SOHCAHTOA because you know this is a right angle triangle. So opposite hypotenuse sine theta is equal to opposite hypotenuse, and you do inverse sine 7, 11.5 theta must equal sine -1 7 over 11.5 it must equal 37.5 degrees. So, like the previous question, you should always refer back to the question when rounding. And there seems to be no instructions, so we're just gonna leave it here. And your therefore statement would be the angle between AG and the plane EFGH is 7.5 degrees. Now, this is a really difficult question because instead of working with cuboids now, we have like a pyramid. So everything, unlike the last question, is labeled out here, so we don't need to do anything with that. We know that this is a square, which is a really important question, and it essentially asks us to work out the size of the angle HF. Now, let me draw this out. HF and D will essentially be this angle. Now, this is let me draw this out. Okay, if we imagine this is the 20 cm point, 20 centimeter point, and this is H, this is D, and this is F, and then we have to find the distance between D and F, find the angle between H, F, and D, which is essentially this. We have to find this angle, and the point with many of these questions is that you must use realistic application-based thinking. And so we know that this is a cube, so let me draw this out. And we have to find this point of the cube. This is 12, and this is 12. So we have to find this slanted line that goes directly to the middle of the cube. And you're just doing Pythagorean theorem real quick. 144 plus 144. Let me just do that real quick. 144. 4 there. We know that C is equal to 16.9705. I'm just going to keep this broad to prevent any rounding errors. Now we know this. So we know that C, this entire total, is 16.9705. And now it becomes really easy because we know that this half point, let's just say 16.9705 over 2. So let me redraw this over here. We have beta 20, 16.9705 over 2 because that is half of this. And it becomes another easy SOHCAHTOA question, right? We have tan theta is equal to opposite over adjacent, 9.75 over 2. Sorry for my bad handwriting. But you should pretty much infer what to do next. And -1, move that down. So let me just get that done real quick. -1, 16.9705 divided by 2. And it essentially gives us a value of 67.0 degrees. As such, you should refer to a question of rounding, but in your therefore statement, it would be the size of angle HFD is around 67 degrees, and that is solving 3D shapes.